In this video, we're going to be setting up the forms for partial fraction decomposition. So there's a number of different forms, but basically it breaks down into two possibilities, main possibilities. It depends on if the factors in the numerator are linear or quadratic. And so in general, we're going to say that our rational expression, the fraction basically that we're trying to decompose, is of this form, f of x over g of x, where both of these represent polynomials. Now, something to note here, for this process, we want the degree of the numerator of f of x to be less than the degree of the denominator. So like if this has its highest term being maybe an x squared, we would want the denominator to have at least an x cubed in it. Now, if the degree in the numerator is higher, we can still do this process, but we'd have to start with long division, and I'll go over one of those examples in another video. So let's start with linear factors. So we are going to look at the cases when our denominator contains linear factors. So linear, just recall what that means. That's when our variable has just the first power on it, so like x to the first power. So for example, and these are just a few of different examples, so we'll call them that. Our numerator, let's just stick to calling it f of x. Let's say that our denominator breaks down or factors into ax plus b times cx plus d. Okay, so we factored whatever our denominator was, and this is the result. Now we can recognize that these are linear factors because there's these invisible ones on our x, on our variable. Now the format for the decomposition would be the following. We have one of each of these linear factors, so one of them goes in one denominator and the other goes in the other denominator. Now we're looking for what numbers are going to be in our numerators, and we don't know them, so for now we give them variables, and we're going to call them capital A and capital B. So this would be our setup, and we would later go on and solve this. Okay, that's one example. Another example, and this is also with linear factors in the denominator. Let's stick to our f of x being our numerator. Okay, and maybe we have ax plus b. This time, let's square it. Okay, and then we have cx plus d, and that one's still just occurring once. Now this makes a difference in our setup. We are still going to put ax plus b in one denominator and cx plus d in another, but because this factor here, ax plus b, because it occurred twice, we actually have to account for that by putting it in a denominator as one factor and then putting it in another denominator as its squared factor, or the number of times it repeated. So we're going to end up with three terms here. So we're going to have an ax plus b, that's this factor here, but now because it's squared, we also need an ax plus b squared in our denominator, and then the last one's going to contain the cx plus d. Okay, so if you have a term, a linear term, with a power higher than 2, higher than 1, so if you look back here, last time this was just to the first power. Now it's squared, so you break this down into that factor by itself, and then another denominator with that factor squared. Now if this was a 3, if this was to the third power, we would do a third one, and we'd have ax plus b to the third power. Okay. And now because these are linear factors, we're going to go ahead and put just our constants in our numerators, so we'll call them a, b, and because we need another one, we'll call it c. So that would be the setup here, and then again we would go on and solve it. And let's do one more example for linear factors in the denominator. Okay. So f of x, and this time let's go ahead and say that our denominator has ax plus b to the third power. Right. So when we break this down, we're going to end up with three terms here. We're going to have our ax plus b as one of the denominators. Then we're going to take, because there's a total of 3 of these same factors, then we're going to have ax plus b squared all the way up to ax plus b cubed. Okay. If this was a 4th power, then we would add another one here. And then they were linear factors, so we put our constants on the top that we'll solve for. Okay, so these are examples of setting up the form when our denominator contains linear factors. Okay. Now we're going to do the same process, but our denominators are going to contain quadratic or irreducible quadratic factors. Okay. So now we're going to be seeing our variables squared. So like an x squared. So this is quadratic factors. Right, so example, we have our f of x as our numerator again, and our denominator this time, let's say that it's ax squared plus bx plus c. Okay, so this is going to give us a different numerator than we've seen with the quadratic factors. Okay, so we're going to have a bx plus c as our numerator, and this is over our quadratic denominator here. Okay, so again, let me point out the difference. When the denominator has this quadratic, or you recognize that it's a quadratic form down here, you have your x squared. Your numerator changes from when you had linear factors down here. When you only had x to the first power down here, you only put a constant in the numerator, like we were only putting a or b or c. Now, because there's an x squared in here, we're actually putting a linear term in the numerator. We're adding x into the mix. Okay, that's the difference. All right, let's see if you recognize it in this next one. So f of x over, this time we're going to say ax squared plus bx plus c, and we're going to square this one. Alright, now just like we did with the linear factors, we're going to repeat this denominator. Okay, so one of these fractions is going to have just the denominator before we square it, and then the second fraction will have our squared denominator. Alright, now for our numerators, again, because we're dealing with a quadratic denominator here, we are going to use an x. That's the easiest way to say it, an x in our numerator instead of just a constant. So we have bx plus c. And then over here, just to use different letters, I'm just going to say dx plus e. So if the denominator has quadratic, a quadratic term in it, then you need an x or a linear term in your numerator. All right, let's try one more. So we have f of x. This time we're going to say that it's over x times ax squared plus bx plus c times ax plus, actually I need to change some letters up because it's going to get a little bit confusing. We'll call this dx plus e. Okay, so dx plus e. Just trying to throw some different things in the mix for you to see. Alright, so this is a mixture. Notice we have actually two linear factors. This is x to the first power. There's also an x to the first power here. Then we have a quadratic factor right there. So we're mixing the two ideas together here. So we're going to have one denominator with just the x, another denominator with our single quadratic denominator here, our single quadratic factor, and then our third denominator with this linear factor here. Okay. And now for all of the linear denominators, so just x to the first power, so again, let me just show you the first power, and this one's to the second power. Because it's linear, the first power, these are the ones that get a constant. Now, because this one's a quadratic term in the denominator, this one's going to get a linear numerator, or a numerator with x in it. So we'll call this cx plus d. Okay. My letter choices don't really matter. The A, how I'm saying like A here, B there, C and D. It's just to change up the letters. I don't want to call everything the same letter. So I'm just kind of going in order through the alphabet. Alright, so this is another form that we might come across.